Hi everyone, welcome back to Made Everything Official. From raw metal to a precise surgical tool, the entire process unfolds through the capabilities of the NTX 2500. What we see here is not just machining, it is the transformation of material into an instrument of accuracy and trust. It begins with a solid workpiece, clamped firmly within the CNC machine. The cutting tools engage with controlled force, removing layers of metal and shaping the initial geometry of the surgical hammer. Every motion is guided by pre-programmed paths, ensuring precision that manual methods could never achieve. As the cycle continues, drills, mills, and turning tools come into play. Each step refines the form. Cylindrical sections are turned, grooves are cut, and surfaces are milled flat. The process is automated, but carefully monitored. Sensors, coolant, and programmed adjustments guarantee both accuracy and consistency. The machine transitions seamlessly between operations. Without needing repositioning, the NTX 2500 shifts tools and approaches, performing complex cuts in a single setup. This efficiency not only saves time, but also reduces error, a crucial factor in the production of medical instruments. By the end of the sequence, the once rough blank has become a finished surgical hammer. Its surfaces are clean, its proportions exact, and its geometry perfectly aligned. What began as raw stock now meets the highest standards of precision, ready for finishing, inspection, and eventual use in the operating room. Here we see a fully automated cell where precision is verified at every step. A system designed to drill, tap, and inspect with robotic efficiency. The process begins at the in-feed inspection station. Each workpiece is carefully positioned and checked before machining begins, ensuring accuracy from the very start. Every feature is accounted for, with up to 71 points of inspection guaranteeing that nothing escapes quality control. Next, the drilling sequence unfolds. 27 holes are drilled and tapped with perfect alignment, each cut driven by CNC logic and robotic handling. At Drill Station 2, specialized heads operate in coordination, while advanced sensors keep constant track of tool conditions. Each drill unit relies on BK micro tool checks, technology that monitors wear, breakage, and consistency in real time. Throughout the cell, precision is paired with efficiency. Robots load and unload, inspection systems verify dimensions, and drilling units perform with unerring consistency. Every stage is automated, yet deeply controlled, creating a balance of speed, accuracy, and reliability. The process advances to Drill Station 3, where additional holes and threads are completed. Coolant flows across the cutting surfaces, maintaining tolerances and extending tool life. Robots manage the flow of materials seamlessly, moving each part from station to station without human intervention. By the end of the cycle, the raw component has become a finished, fully verified part. All drilled, tapped, and measured, it leaves the cell ready for final assembly or integration. This is modern manufacturing in action: automation, robotics, and advanced inspection working together to achieve uncompromising quality. In this cell, raw metal transforms into threaded reality. This is a flow drill and tap machine in action, drilling, tapping, and finishing parts seamlessly in one continuous cycle. A workpiece enters the spindle, firmly held and precisely positioned. The flow drill bit pierces the material, creating a hole without pre-drilling. The metal is pushed aside rather than removed, forming threads within the newly made cavity. Next, the tapping tool takes over. With perfect alignment, it cuts threads into the material, creating internal fasteners ready to receive bolts or screws. All motion is controlled by CNC, ensuring consistency from part to part. Throughout the process, coolant flows to manage heat, protect the tool, and preserve accuracy. Robots or automated conveyors may handle part transfers, maintaining a steady workflow. At the end, the component emerges with smooth, precisely cut threads, ready for use in assemblies. The flow drill and tap system showcases how innovation in machining can streamline process, reduce steps, and deliver quality metalwork in one seamless operation. Step inside the world of precision machining at MTAC Precision Engineering. Here, solid blocks of metal are transformed into components with micrometer-level accuracy. Each workpiece begins clamped firmly in the machine. The CNC system guides advanced tooling across multiple axes, trimming and shaping surfaces, turning rough material into precise parts. Every motion is calculated, every vector controlled. Tool changes happen seamlessly. The system swaps cutters automatically, engaging milling, drilling, or turning operations without human intervention, ensuring consistency and speed. Coolant sprays protect the tools and parts, regulating heat and preserving surface quality. Sensors monitor vibration, tool wear, and dimension conformity in real time, making adjustments on the fly to maintain strict tolerances. By the end of the cycle, raw metal is refined into finished parts. Every surface, every edge, every feature aligned to specification. This is high-precision CNC machining at its finest. Efficiency, automation, and exacting accuracy brought together under one roof. Watch as the heart of precision arrives and is brought into motion. The installation of a DMU 600P machine begins, a giant stepping into place in a world of tight tolerances and heavy engineering. The process starts with positioning. Cranes and transport equipment carefully place the machine into alignment as engineers adjust its base with exacting care. The foundation must be flawless, for even the slightest misalignment can ripple through microns of error. Once seated, utility connections are made, bringing power, coolant systems, and control lines into the heart of the unit. Hydraulic and electrical hooks are locked in, preparing the machinery to operate under full load. Alignment checks follow. Precision instruments verify level, squareness, and spindle center. Every axis is set, every surface reference confirmed. Only when all parameters align does calibration begin. As the installation proceeds, the machine's axes are activated. Movements are tested at various speeds, axes glide with smoothness, and initial motion paths are checked for consistency. Adjustments ensure that axes operate without backlash or deviation. Finally, integrated systems engage. The DMU 600P is ready to accept tooling, accept raw workpieces, and respond to control signals. What was once a lifeless frame now stands as a precise, multi-axis machining center, ready to shape metal into components that demand excellence. From the very start, this CNC turning center demonstrates an incredible combination of speed and precision. The machine operates at rapid travel rates of up to 30 meters per minute, ensuring that even complex parts are shaped quickly without compromising accuracy. What makes this system especially advanced is its ability to perform simultaneous machining with 3 tools at once. By cutting on multiple surfaces in parallel, production times are drastically reduced while maintaining a balanced load across the workpiece. This balanced cutting helps extend tool life and ensures surfaces remain smooth and consistent. The setup includes a tailstock positioned over the subspindle, which allows longer and heavier parts to be machined with full stability. Even with the tailstock engaged, the machine can deploy two turrets working together, showing just how versatile and powerful this platform is. At the same time, live tools reaching up to 12,000 revolutions per minute make it possible to drill, mill, and finish with extreme precision, all within the same cycle. Once a machining sequence is complete, the tailstock disengages automatically, transitioning smoothly into the next phase. The system also supports synchronous machining, where both spindles coordinate perfectly to process different ends of the same part simultaneously. And when the job is done, a pneumatic parts catcher swiftly retrieves the finished component, readying the machine for the next cycle with almost no downtime. This demonstration highlights not just raw speed, but also engineering intelligence. By combining multiple functions into a single continuous flow, the CNC Turning Center proves itself as an essential solution for modern, high-volume, high-precision production. The machining cycle begins with a simple raw blank, clamped tightly in the jaws of the Eurotech Rapido. At this stage, the material is nothing more than a cylinder of metal, waiting to be shaped. Yet within minutes, it will be transformed into a precision-engineered component. The spindle comes to life, accelerating smoothly, and the first turning tool engages the surface. With each pass, the rough exterior is peeled away, revealing the foundation of the part. As the first turret continues, the Rapido's second turret swings into position. Now, two tools are working in harmony, one removing stock from the outer diameter, while the other prepares internal features. Balanced cutting spreads the load evenly, suppressing vibration and accelerating progress. This ability to perform operations simultaneously is what allows the Rapido to finish complex parts more than 40% faster than conventional cycles. Coolant sprays across the contact points in precise streams. At high speed, cutting tools generate enormous heat, but the coolant stabilizes temperature, preserves edge sharpness, and flushes chips away from the path of the tool. Each metallic shaving is carried clear of the work zone, ensuring that the surface remains clean for the next cut. Behind the scenes, sensors are monitoring every aspect: spindle load, feed rate, axis position, and even tool wear. The system continuously adapts, fine-tuning parameters to maintain accuracy within microns. The cycle advances to drilling. Specialized tools penetrate the workpiece, boring precise holes in perfect alignment. Without pause, tapping heads follow, cutting internal threads directly into these openings. The part is no longer just a shape. It is acquiring functional details that make it ready for assembly. Thanks to live tooling, all of this occurs in one setup, eliminating the need for secondary machines or manual transfer. Tool changes occur with fluid efficiency. As soon as one operation ends, the turret rotates, presenting the next tool instantly. There is no wasted motion. At the same time, the subspindle moves forward, gripping the part from the opposite side. The tailstock engages, stabilizing the workpiece, and ensuring that even long, slender geometries remain rigid. This dual support is critical for holding tolerances when machining extended shafts or components with delicate features. Milling operations now take over. End mills and slot cutters shape grooves, flats, and complex patterns into the turning surface. Each axis moves in harmony. X, Y, and Z glide together, tracing paths that generate intricate geometries. It is in this moment that the Rapido demonstrates its multitasking ability. Not just a lathe, not just a mill, but a true hybrid machine capable of everything in one cycle. The pace is unrelenting. At 30 meters per minute in rapid positioning, tools reposition with blinding speed. 3 tools can even cut simultaneously, maintaining balance and symmetry as material is removed from multiple sides. Live tools spin at 12,000 revolutions per minute, their sharp edges slicing through metal with surgical precision. Even as these aggressive operations unfold, the machine maintains control, constantly checking alignment and compensating for microscopic deflection. As the roughing stages end, the process transitions into finishing. Here, lighter cuts are made, shaving away the final microns of material. Surface finishes improve dramatically, from rough textures to smooth, reflective planes. The noise of heavy cutting softens into a steady, controlled hum. The workpiece is now approaching its final form, every contour sharpened, every dimension brought within tolerance. Meanwhile, verification steps are integrated directly into the cycle. The machine pauses briefly as probes measure key dimensions, ensuring that each stage meets strict specifications before moving forward. This in-process inspection reduces scrap, guarantees quality, and provides assurance that the finished part will pass final checks. Finally, the last operations are performed. Edges are chamfered, threads cleaned, and surfaces polished. The part is released from the main spindle and caught gently by a pneumatic parts catcher. Coolant drains away, tools retract, and the machining center falls silent. The raw blank that entered minutes ago has become a complete high-precision component, finished in one continuous, uninterrupted cycle. What this demonstration reveals is more than just speed. It showcases the future of manufacturing, where efficiency, intelligence, and precision converge. The Eurotech Rapido does not simply cut metal, it orchestrates a finely tuned performance, synchronizing every tool, every axis, every sensor. The result is not just faster machining, but smarter machining. A process once requiring multiple setups, long hours, and separate machines is now compressed into a single seamless workflow. The cycle you have just witnessed captures the essence of modern CNC capability. From raw stock to finished part, from aggressive roughing to delicate finishing, the Rapido delivers excellence at every stage. It embodies the pursuit of perfection in metalworking, where speed does not compromise quality, and precision is achieved not at the end, but maintained throughout the entire process. This is how a Hammerhead T-bolt is made, a process of strength, precision, and careful engineering. The journey starts in the forge. Heated steel is pressed under immense force, shaping the rough hammerhead profile. This forging not only gives form, but also strengthens the grain structure, ensuring durability where it matters most. From here, the forged blank moves to machining. Cutting tools refine dimensions, smooth surfaces, and bring the bolt into exact tolerance. Shoulders are squared, and the hammerhead form is sharpened to its final profile. Threading follows, as tools cut precise grooves into the shaft. These threads transform the blank into a fastener capable of reliable, repeatable connections. Every cut is measured for accuracy to guarantee performance. Heat treatment hardens and tempers the bolt, balancing toughness and resilience. Finally, finishing steps smooth and protect the surface before each bolt undergoes inspection. In just over a minute, the raw steel bar has become a high-strength hammerhead T-bolt, ready for use in structural and industrial applications.